Good morning, students. Welcome to experiment 6 of the CCN lab, that is implementation of link state routing algorithm. The link state routing algorithm comes under shortest path first routing algorithm and also open shortest path first algorithm. Now, this particular link state routing algorithm, it reduces the time taken to transmit data from source to destination. It also improves the overall performance of the network. It builds a topology map of all the particular nodes, and the router can independently determine the shortest path in every network. And in link state algorithm, it routes the packets, finding the best particular route for the data transfer using the cost of the link. Now, if you see in the particular diagram, here I want to send packets from node N0 to N4. So N0 is the source node, N4 is my destination node. So if I'm using UDP at the source, at destination we will be using null. And the traffic agent for UDP is CDR. Clear? And here we can see I have created a particular network of consisting of 5 nodes starting from N0 to N4, and each particular node, that is between the nodes, we have different links, right? So N0 to N1 we have a link and the link cost is 2, and N0 to N3 we have the link cost that is 1. Again N0 to N3 we have the link cost that is 3, and N2 to N0 is 1, N2 to N3 is 1, and N1 to N3 is 3, and N3 to N4 is 2. Clear? So now let us see the program. So similar to your other programs, first you will set uh, the simulation time, at what time it has to end, using the set val stop, that is equivalent to 10, and then you are going to create a new simulator. You will open a trace file to trace all the events, and you have to keep track of all the events that is happening in the trace, followed by opening a NAM file, that is the animator file, to show you all the animations that is happening corresponding to the experiment. And then you create 5 nodes, that is using the command set n0 $ns node. Similarly, set n1, n2, n3 and n4. And after creating all the 5 nodes, now you have to establish links between the corresponding nodes. So you're going to create a duplex link between N0 and N1 having a bandwidth of 10 megabits and delay, and the drop tail mechanism being the queue mechanism being drop tail, and also setting the queue limit, that is 50 between N0 to N1. Similarly, duplex link between N0 and N2 with certain bandwidth, delay and the queue mechanism with a queue limit of 50. And the same thing for N2 and N3 with same bandwidth, delay and the queue mechanism with a queue limit of 50. Similarly, between N1 and N3, N3 and N4, N0 and N3, and N1 and N2. Now, after creating the duplex links between the corresponding nodes, we have to orient them in the particular order. So here there will be a duplex link between N0 and N1, but the orientation from N0 to N1 is orient right, that is your N0 is to the right side of, your N1 is to the right of N0. And similarly N0 and N2, so between N0 and N2, N2 is oriented right down, towards the right and little towards the downwards. And then orienting N2 and N3, that is N3 is to the right of the node N2. Similarly N1 and N3, you are going to orient N3 to left down with respect to N1. Again N3 and N4, it will be oriented left down with respect to N3. And between N0 and N3, N3 will be oriented right down with respect to N0. And N1 and N2, N2 will be oriented left down with respect to N1. Now after doing the orientation, you have to set the cost of each particular links that we clearly saw. Now here, between using the command ns cost $n0 $n1 and the cost here, and this 2 indicates the cost. So here between N0 and N1 the cost is 2. Between N0 and N2 the cost is 1. Between N0 and N3 cost is 3. Similarly, the individual cost from N1 and N0 is 2, N1 and N2 is 2, N1 and N3 is 3. The cost between N2 and N1 is 2, N2 and N0 is 1, N2 and N3 is 1, N3 and N2 is 1. Between N2 and N1 it is 3. Between N3 and N0 it is 3. Between N3 to N4 it is 2, and even N4 to N3 it is 2. Clear? Now after doing that, we have to set the UDP connection. So UDP 0 is the new agent which we are going to call for the source, and the agent which you have to attach to node N0 is your UDP 0. So N0 being the source, so attach agent N0 to UDP 0. Similarly for the destination, the new agent you are calling is null1. Clear? And you will attach the agent null1 to N4 using the command ns attach agent $n4 null1. Now you have to connect between the UDP 0 to the null, that is from the source to the destination, using the command ns connect $UDP 0 $null1, and you will set the packet size to 1500. Now after that, you have to set up the CBR application over the UDP connection, whereas if you are using UDP, your traffic agent application is CBR. So set CBR 0 new application / traffic / CBR. So you will attach CBR 0 to UDP 0. So CBR attach agent UDP 0. Next, you will set the packet size using CBR 0 set packet size underscore 1000, and you will set the rate, that is 1 megabits, and CBR 0 is set to random null. So this 2 steps initiate to tell at what instance the packet will start sending, at what time the packets start are getting transmitted and at what time it will stop. And here, so at 1 second it will start transmitting, at 5 it will stop, the traffic data will stop. And now ns rtproto space ls. Here RTP ROTO indicates a routing protocol. This indicates a routing protocol, and this indicates link state. Here, now after this, we will do the finish procedure. We'll define the finish procedure. So in the finish procedure, we are going to include, that is globally, whichever variables you call the usimulator, the trace file, NAM file, and you'll flush all the trace, what all events you trace, you will flush it into the trace. You'll close the trace file, you'll close the NAM file, and you'll execute the particular program. Here using this execute nam lab6.nam ampersand exit, and here, so whatever particular value you have already given at that particular, that is we had given at 10, the value is 10, it has to finish the iteration there, and you can use this ns at stop val puts slash done slash ns halt. Either if in case you have paused it and you rerun the particular program, it has to run from that particular distance, and dollar $ns. Here this is the entire program. Now when you run the particular program, save and run, you will come across a window which is like this. So all the particular nodes are created: n0, n1, n2, n3, and n4, and you can see the packets that are flowing. Clear? So let us see the particular output. So if you see here, initially all the particular nodes will first communicate with all the corresponding nodes and calculate the cost and study the cost with respect to all the neighboring nodes. Here, once it communicates with all the corresponding nodes, it will come up with a best possible path using the cost between all the particular links. Now once it calculates all the cost, it will find the best possible path between the source, that is node 0, and the destination, that is node 1 and node 4. Clear? So if you see clearly, from node 0 to node 2, from node 2 to node 3, and node 3 to node 4. You can clearly observe that now. So listen to the path, that is node 0 to node 2, node 2 to node 3, and node 3 to node 4. So this is the best possible path depending on the cost. Clear? So link state will find the best possible path based on the cost of the links. So now you can see the animation. You can see from node 0 to node 2, node 2 to node 3, and node 3